All right, let's talk about one of those classic chemistry problems, balancing redox equations. But we're not just doing a boring review. Oh no, we are going to tackle that one type of exam question that's designed to make you panic, the one where the answer you need isn't in the book. Let's get right into it.
So picture it. You're in the exam, heart's pounding a little, you flipped your data book for a half equation you need, and it's just not there. What do you do? Well, don't worry. By the end of this, you'll know exactly how to build that equation completely from scratch, every single time. So here's our game plan for today. We're going to start with a quick refresher on the easy stuff, simple half equations. Then we'll dive headfirst into the real exam challenge. We'll break down a two-step method, first balancing atoms, then balancing charges. And finally, we'll put the whole thing together. Let's go.
Okay, Section 1, the simple half equation. Let's just make sure we're all on the same page and get this foundation nice and solid before we get to the tricky stuff.
Let's start with the really common reaction. You drop a piece of iron into some copper sulfate. On the left is the full equation, but look closely at that sulfate ion, the SO4. See how it's on both sides, totally unchanged? We call that a spectator ion, because it's literally just watching the reaction happen from the sidelines. So if we pull it out, we get the ionic equation on the right, and that shows us what's really going on.
So this whole thing actually happens in two parts. First up, oxidation. Our neutral iron atom, Fe, loses two negatively charged electrons. And since it lost two negatives, it ends up with a positive 2 charge. You probably remember the little saying, oil rig, oxidation is loss of electrons.
So where do those 2 electrons go? Well, they don't just disappear. The copper ion, Cu2+, snags them. It gains those 2 electrons and becomes a neutral copper atom, and that's reduction. Back to our mnemonic, OILRIG, reduction is gain of electrons. See? Simple enough. Now, 9 times out of 10, you wouldn't even have to think about this. You just flip open your data book, find these 2 half equations, and you'd be good to go. But that leads us to the big question, the whole reason we're here. What happens when one of them just isn't there? And that brings us to our main event, the exam challenge. This is where we stop just looking things up and start really understanding the chemistry behind it all.
Okay, check this out. This is a real problem from a past exam paper. Copper reacting with nitric acid. That overall equation looks pretty intense, right? But we know the process. We need to find the 2 half equations that make this happen.
Now, the copper part is easy. We know copper goes to copper 2+, losing 2 electrons. We can look that up. But what about the nitrate ion, NO3-, turning into nitrogen dioxide, NO2? If you go look for that specific reduction in your data book, spoiler alert, it's not there. This is the piece we have to build ourselves. So how in the world do we build an equation from scratch? Well, it's a 2-step process. First, we're going to completely ignore the charges. Just pretend they don't exist for a minute. Our only job is to make sure we have the same number of each type of atom on both sides of the arrow.
Let's walk through it. We start with our core, NO3- on the left, NO2 on the right. Okay, first problem. We've got 3 oxygens on the left, but only 2 on the right. The rule for acidic solutions is simple. To balance oxygen, you add water molecules to the side that needs more. So we add 1 H2O to the right side. Great, but now we've created a new problem. We have 2 hydrogens on the right and none on the left. The final rule is just as simple. To balance hydrogen, you add H+ ions to the other side. So we add 2 H+ ions to the left. And now, let's check. 1 nitrogen, 3 oxygens, 2 hydrogens on both sides. Perfect, the atoms are balanced.
All right, the atoms are all sorted out. We're halfway there. Now we can move on to the second and final step of building this thing, balancing the electrical charge. Let's do a quick charge tech. On the left side, that nitrate ion has a charge of -1. And we have 2 hydrogen ions, each with a +1 charge. So, -1 + 2 gives us a grand total of +1 on the left. Now for the right side. Nitrogen dioxide and water are both neutral molecules, so their charge is 0. The total on the right is 0. Okay, so we've got +1 on one side and 0 on the other. That's not balanced.
So how do we fix it? The rule here is dead simple. You can only add one thing, electrons, which are negatively charged, and you always add them to the more positive side. For us, the left side with its +1 charge is definitely more positive than the 0 charge side.
To get that +1 charge down to 0, we just need to add one negative charge. So we add one electron, one E- to the left side, and just like that, the total charge on the left is now 0 and the right is 0. It's balanced. And there it is, our complete, fully balanced half equation that we couldn't find in any book. We made it ourselves.
We have done the really hard work. We built our missing equation from nothing. Now for the grand finale. We just have to combine our two half equations to get the overall ionic equation for the whole reaction.
So here they are, our two finished pieces. We've got the oxidation of copper, which is producing 2 electrons, and we have our shiny new reduction equation, which is only using up 1 electron. Do you see the problem here?
Here's a fundamental, non-negotiable rule of redox chemistry. Electrons can't just appear or disappear. The number of electrons lost in oxidation must be the exact same as the number of electrons gained in reduction. Right now, we're losing 2, but only gaining 1. That's not going to work.
But the fix is super easy. To make the electrons match, we just need the reduction reaction to happen twice for every one time the oxidation happens. So we take that entire reduction equation and we multiply the whole thing by 2.
When we multiply that second equation by 2, and then we add the two equations together, this is what we get. The 2 electrons lost by the copper are now gained by the 2 nitrate ions. The electrons on each side cancel out completely, and we are left with our final, perfectly balanced ionic equation.
And that, my friends, is the solution. This is the core reaction that was hiding inside that big, complicated mess we saw at the start. And we figured it out from scratch, without needing the data book for the hardest part.
So let's just recap that toolkit one more time. First, you spot the half equation that's missing from your databook. Second, you balance the atoms using water and H+ ions. Third, you balance the charge by adding electrons to the more positive side. And fourth, if you need to, you multiply one or both equations so the electrons cancel out when you put them together. That's the method.
You say, this is so much more than just a trick to pass an exam. It completely changes a problem from something you have to look up into something you can actually figure out. So the next time you see a weird reaction you've never seen before, don't panic, you've got the tools. The only question left is, what other impossible equations are you going to solve now?